Hi, my name is Hugo John. My ZID is Z5309233, and this is a photo of my ZID. Kepler has three laws, which have greatly informed what we know of how planets move around the Sun. They are known respectively as the law of ellipses, the law of equal areas, and the law of harmonies. As outlined by the work completed by the Physics Classroom and the NASA Science editorial team, Kepler's first law, otherwise known as the law of ellipses, outlines how planets move in elliptical orbits with the Sun as a focus. His second law, otherwise known as the law of equal areas, dictates that a planet covers the same area of space in the same amount of time, no matter where it is in its orbit. This is not saying that planets are orbiting the Sun at a constant speed, as they in fact speed up closer to the Sun and slow down when they are further away. It is saying that the same amount of distance is covered by a planet over, say, a 5-day period when it is further away from the Sun compared to a 5-day period when it is closer to the Sun. And his final law, also known as the law of harmonies, specifies that a planet's orbital period is proportional to the size of its orbit. In other words, the further away from the Sun a planet is, the longer it will take to complete an orbit. Further, his law outlines that it is not a linear relationship, as shown by the equation T times T squared times by A cubed, where T represents the time it takes to complete a planet's orbit around the Sun, and A representing the planet's average distance from the Sun. Moving on to question 9. The planet does move as the Moon orbits. Further, the center of mass of a planet orbiting the Sun is approximately at the center of the Sun. However, for a planet-Moon orbit, the center of mass is located at a point between the two bodies. On to question 11. The distance between each grid line is 73,210,139 kilometers approximately, which translates to roughly 0.489 AU. When recording the time it takes planets to orbit the Sun, the following results were received. For a planet 0.489 AU distance away, it took 126 days. For a planet 0.9832 AU away, it took 360 days. For a planet 1.5 AU, it took 675 days. And for a planet 0.1 AU, it took 9.5 days. These results all roughly follow Kepler's third law. Moving on to question 15, I would expect Mercury to have the fastest orbital speed, and I would expect Neptune to have the slowest orbital velocity. The reason for this, as described by Lumen Learning, is due to Kepler's third law, that a planet's orbital period is proportional to the size of its orbit. As Mercury has the shortest orbital period, it must travel the quickest, and vice versa. As Neptune has the longest orbital period, it must travel the slowest. Researching for this experiment, I learned the extent that Kepler's three laws, specifically his law of harmonies, influenced Isaac Newton's notion of gravity. As the editors of Encyclopaedia Britannica outline, Newton used and modified Kepler's third law to show that the movement of planets could be explained by mathematics and physics, which I did not fully understand until undertaking this experiment. Thank you.